we were talking about neural architectural search, and we've analyzed this idea in 3 main steps. The first step was the search space, in which different architectures could be found in a set. The second one was the search strategy. With what kind of strategy are we searching this space, the architectures, and actually the performance estimation strategy, which works iteratively with the second step. So you estimate the performance for an architecture, then you search for another strategy depending on your performance estimation coming from this block, and by looking at the search space, and this goes and on and on and on, and you find a proper architecture giving you the best performance. So you maximize the performance. Okay, we start with the search space. So you got this same figure around here. This figure is taken from this paper actually, guys. This paper actually. This is a very good paper. I strongly recommend you read this paper, guys. So yes, let's look at the slides, and the first one is search space. So search space defines what neural architecture our neural architectural search approach might discover. So this is the set. This is a set of different architectures. It can be a chain-like architecture, which means you know which architecture to try the next one. So they are linked to each other. The first we try this, then we try this, then we try this. But this does not necessarily be a simple link. Maybe they are linked like a tree. So depending on the choices, we either select one or this one or the other one. So they are chain-like structure. Or it can be a more modern, complex architecture with many different connections. So we decide what kind of a search space we have. Maybe in the search space we have many structures with different number of layers. We increase the number of layers. Or maybe in your search space you fix the number of layers, but inside the layers you make some small changes. Each layer represents a module. It can be anything, but you define and design a search space. That search space will designate your search strategy and your performance estimation accordingly. So it's very important how you define it, guys. So you will handcraft this search space, and you will change different parameters. The search strategy, the next step, this guy, will change the parameters inside, and they will find. So it could be anything. The parameters inside the search space could be anything. Maybe layer connections, which layer to connect. Maybe you are going to cut some connections. You're going to change filter numbers, filter sizes. You're going to change the number of layers. Maybe you have different cells, different modules. You're going to change those modules, but keep the architecture fixed. Actually, we have all these strategies. In search strategy, we are going to discuss those. But this is the set. This is the set, the universal set of the possibilities for your experiment. You are doing a neural architectural search experiment, and this is the event space. Very good. It's simple. So it is the event space. What will help you is if you incorporate prior knowledge about typical properties of architectures, which is well suited for a task, the task you're using, this can reduce the search space. So this is where you do the handcrafting. So in your search space, the possibilities are limitless. But if you're going to do semantic segmentation, and if you know that a U-net structure works well for semantic segmentation, maybe you confine your set to U-net variants. So you will handcraft it depending on the task. And if you make this search space smaller, the search strategy will converge better, and you will maximize your performance more easily. Or you will be able to maximize your performance, because in most cases, if this search space is huge, vast, you may not be able to find your way when you're searching if you don't have the correct strategy. Okay, but when you do this, I intentionally use this word handcrafting. You add this human bias. So when you make the search space smaller, okay, it will still work automatically, but you're confining the search space. This will add a human bias, which will prevent finding novel architectures, because you're confining the search set, but maybe the best result is somewhere as an outlier in your space, and when you make that search space smaller, maybe you lost it. So it is a trade-off. You keep a big set, it will be difficult to converge the search strategy. When you make it small, where you're killing your possibilities. That's the trade-off of the search space. And this is still a human bias, and this is still a handcraft you make. But still, as you can see, we have moved handcrafting from features to deep learning, and we've automated it. And at this layer, we are moving the architecture to automatically doing it, and we need to handcraft things, and this is what we handcraft. Still, there is handcraft. Okay. For example, let's start with an example. You can handcraft a search space with different design parameters. As we talked, they could be layer connections, filter numbers, filter sizes, different modules, and this will create infinite possibilities of architectures. So in your search space, when you change a connection with another, well, this will create infinite possibilities. Imagine you have a base network structure where you have many layers and many parallel layers as well with connections. It could lead to a simple structure as well as a structure like this one, which looks like an inception module. It's not an inception module. What I'm trying to say is it has also serial connections and wide connections and skip connections. So if you define your search space structurally well, you will create enough possibilities to search. And with a nice search strategy, you will create the nice architecture you're looking for. So Google guys have handcrafted this inception module 5 years ago, but today they are finding it by neural search. I'm going to show you a neural search paper in these slides, in the following slides, in these videos. And it's by Google as well. The same guys who have designed the inception module have been working on it for a couple of years, and they said, okay, why handcraft this? Let's find an architecture which will find the perfect inception module for us. That's how it is done. So I guess we have an idea. By the way, guys, about this week, as I've mentioned in the first video of this week, we are trying to find a future direction. We are trying to understand where the field will go from now on. It will be very difficult to understand or go in detail over these studies. I'm going to give you a glimpse of what these guys are trying to do. If you want to understand them, I will provide many references in these videos. Go and watch those videos. Otherwise, this is just an introduction to the subject, because this is one of the last videos of this course, and I'm trying to tell you what you can learn when you continue this field. So don't think that you will be able to understand a neural architectural search with this lecture. This is just an introduction to it. That's what I think it's better for a graduate course last week video. So yes, I'm going to go over them a bit superficially. That's why, yes, you will get the glimpse of it, but you may not be able to perfectly implement them unless you go and study and read those papers. Okay, just to give you an idea about it. Okay, let's continue these on the next video.